Hi, and welcome to the Taiwan Semiconductor video about new surge rating specifications and miniaturization. Rectifiers are generally rated by their currents, like a 1 amp or a 2 amp device, but especially in AC to DC conversion of less than, let's say, 75 watt, the power factor correction norm, a better way to classify rectifiers would be by their surge current ratings, like 30 amp or 50 amp devices. In this video, we're also going to discuss a new 1 millisecond surge specification and datasheets that we hope will help the designers. If you look at the new products we introduced, you would say at first there's nothing special about them. On the left, you see the tin SMA. On the right, you see the SOD 128. Both devices are rated up to 1000 volts, 2 amps, and with a 50 amp 8.3 millisecond surge current. But we'd like to show you some other features of these devices that may surprise you. So let's first look at rectifier development where we stand at the moment. We're looking at transient thermal impedance, thermal resistance, package height, and process improvements leading to zero defects. Actually, applications can be split in two parts. Those where the transient thermal impedance dominates, where you have short pulses and surges, or those where there's a larger steady-state power dissipation. And then the thermal resistance is the key factor. Of course, in some applications, both are important. Now, if you look at AC to DC rectifier rectification in 75 watt power supplies or less, it actually is determined by the surge current that, when you start up the power supply and the capacitor is empty. So actually in these applications, the transient thermal impedance is the most important and critical factor. How is this reflected in the datasheet? So the surge current is going to be the limiting factor in these applications. It's 50 amp. The power dissipation is not that important, so the 2 amp is there, but actually you're going to dissipate a few hundred milliamps in devices and applications like this. So what is important is the die size to get this 50 amp and the transient thermal impedance spec. So this is the most important feature on this datasheet. And what did we help to add? We took it also the specification there at 1 millisecond, that's also on a sine wave, and tested it up to 140 amp. So until recently, we all specified surges with 8.3 or 10 millisecond sine waves. This was actually based on old JEDEC norms, days of the linear power supply and resistive power loads. But now in 2020, we're talking about switch mode capacitors and switch mode power supplies and empty capacitors. So we're going to have these short 500 microsecond or less surges, for typical power supplies like less than 50 watt. So this 1 millisecond action is much closer to what a designer would really see in his design. So let's talk a bit more about surge current rating. Actually, it is guaranteed by design. We don't test this in mass production. So we always tested it in design and have a safety margin. 8.3 millisecond, it's the old spec. It comes from the days of the linear power supplies. Actually, if you look at surges of less than 1 millisecond, you'll see that the transient thermal impedance or the die size actually, in this case, is the dominating factor. So all the heat is dissipated in the die size and the rest of the package actually does not contribute to the application. So the 1 millisecond test we introduced is much closer to what the designer actually sees. But in our labs, we did have to set up special dedicated characterization equipment to test or characterize the components at 1 milliseconds. It meets the requirements of a 50 watt or 75 watt flyback converter. And we see that also important in the surge current rating are the solder voids, because the die has to be 100% contacted to actually handle the whole surge. If there are large solder voids, then parts of the die don't work and you will have early failures. It should be mentioned again that exceeding the surge current actually is a catastrophic failure. The last thing we mention here is that's important is that there is a delta VF test, which tests the devices with a short pulse, and it measures the VF before and after a short current pulse. The VF has a negative temperature coefficient, so if there is an abnormal shift and a bad solder contact, that will eliminate the worst devices out there. So the following table we actually generated with our website. So we select on the right-hand side for 50 amp surge current, all the devices with 50 amp surge currents, and then we also select, in this case, randomly for 800 volts. Historically, these devices were made in SMA packages. That's 50 years ago. Recently, we also made them available, or more recently, we made them available in SMA. And now you can see that actually a lot of new products were introduced that allow this 50 amp surge rating actually in much smaller devices and packages. Let's explain why that is possible. If the dye is a dominating factor, you can tell here this is the SMA package, which is 30 years old. First and for all, the first thing you need to understand is that the heat has to transfer from the dye via the lead frame all the way to the PCB. So it's actually quite a distance the heat has to travel, and each added millimeter adds Kelvin per watts thermal resistance. The second thing is that sometimes in these SMA packages, the ratio of the dye to the PCB footprint is like 10–12% in that area. So there's the package isn't particularly well utilized from a space perspective. If you look at these new packages, like we took randomly here, the SOD123W, you see it's half the size of the SMA package, and you can actually easily see that the heat is easily transferred with short leads out, with the flat leads out on the PCB. So that's an advantage. And if you look, you can easily look at the plus sign is the jumper, which contacts on top of the die, which is the bluish area. So you can actually also see that this has a much better die to PCB or package size ratio. So these new packages allow old or existing die to be packaged in smaller packages, and of course keep the surge rating and a similar performance on surge rating. So a few words about I²T rating. It's actually linked, linked to a certain pulse length. So it's linked to, let's say, 8.3 milliseconds. It's actually, if you transfer it, you can transfer it to, let's say, 1 millisecond by doing calculation and that type of stuff. But that's actually only an approximation. It is not an exact science, so that needs to be clearly stated. The reason for that is, of course, that the VF changes with the current, and as you change the time, you actually also are moving to a different transient thermal impedance part on this curve. So the next thing we also need to point out, of course, that the waveform is important to have the energy contained into it. So it could be, the characterization done with a sine, but most waveforms actually are more exponential. And of course, you actually always have to measure the surge in your circuit. That's actually a very important input. Here we see what happens actually visually. You can see that as the currents go up to 20, 30, 40, 50 amps, the VF actually also goes up substantially. And that's very important to notice actually here in this case also. And of course, as you move down or move in different time zones of the transient thermal impedance, of course, you are going to get different values. One important part to mention, of course, is thin SMA is the height of 1 millimeter. The old packages like SMA were very high. This is an advantage and an amazing amount or a high percentage of input rectification on flyback converters. People like to route it at the bottom of the PCB. And if you do that, then you appreciate the lower height of these components. So that's actually an important advantage of these new devices. So actually, just to summarize, so we actually introduced a couple of new devices. We actually have 1 millisecond surge characterization in the data sheets. We hope that will provide extra clarity for designers. And these new surge ratings will actually help also miniaturization. Thank you for your attention, and thank you for your interest in Taiwan Semiconductor.